Thank you for having me. I'm going to talk about this proposal I made just to please Harald. And I'm going to also talk about the actual standardization process, how it works and why it takes so long to get anything new in the language. So let's go. I'm going to talk about me, the proposal, some examples of what the proposal would bring, standardization process, and I will finish off with showing you a bit of news in the new language versions that are standardized and is going to be standardized. So I'm from Linköping, so it's not that far, but it's still a 2-hour train ride. I was starting on the D line, computer science in Linköping in 1981. That was 3 years before there was such an education in Stockholm, and it has already been running for 6 years by then. So by far Linköping is the place to be in computer science. I've been working with C++ since 1994, and one of the first things I did was units and one of those libraries. Far more primitive, of course, but we had exactly those problems and we found a very similar solution. Now I'm working at Context Vision, which is also one of these early spin-outs from the Linköping University, and we're working in image processing for medical purposes. That's basically ultrasound and X-ray images, where we are market leaders for software that improves the quality of images. And if you have seen these lousy ultrasound images, that's after our improvements. And this company has been working on that task for the last 25 years. So it's hard. So I've made quite a number of proposals, and none of them are in the standard yet. It's hard. I'm going to talk about this one. These were earlier, and there's also some things I'm writing for later. And this one is sort of exciting, I think. It's called, in most languages you can write an F, double quote, and then put your expressions inside the quoted string. That's what we're aiming at. And this is useful for that as a support function, but it has many other uses.
And you contributed a few more, right?
Sorry?
And you contributed a few
Yeah,
more.
I've contributed to a couple of other proposals also. So it's a lot of spare time goes to this work. I have another list which I want to work on, but it's lack of time and lack of inspiration maybe. This I've worked a lot on, labeled parameters. A lot of people have worked on that, and I call it labeled parameters because parameters already have names, but it's basically what you would think it is. You can write the name equals the value at the call site. I won't talk about the other ones. Maybe I should mention this one. There's a lot of talk about safety, and there's a lot of different proposals. I wish I had time to complete this because it's sort of make C++ safe in one go, and that's fairly good. Except that it reduces the performance comparatively largely. So you have to mark stuff unsafe to get back your performance. But this is early stages. I've I think I'm really positive it can be done, but there are a lot of details. That's always a lot of details. So let's go into this actual proposal. What I'm saying is we can have a new specifier implicit instead of explicit on a conversion function, or what you can call a cast operator. So it's even easier to convert this type to that other type, the return type of this function, than it is with a normal non-explicit conversion function. And what does this buy us? It buys us, for one, the operator dot that Harald craves. Because why can't we do operator dot on our class today, which has a normal conversion function? Because it doesn't do that kind of conversion on the left side of a dot. But if it's implicit, it's going to do it because it has the same conversion rank as the subclass to base class conversion, which obviously you can do on the left side of the dot, or you could never inherit the method from the base class. So this is basically it. That's the only thing it does. And the paper is about 20 pages. It goes through all of the different aspects that differs between normal function and override or base class conversion. So you have to cover all the bases, find all the corner cases, explain how all the corner cases work, and that's usually the big part of the work. And then when you present it, someone says, well, did you think about this? And there's another corner case there. So we can have a look at how this would work. Here is a super simple proxy class to the type T. I can actually use the lace pointer instead. So the proxy class can, of course, deliver a reference to the T that the pointer points to. As it does this implicitly, we can now do a lot of things with this proxy object that we couldn't do if it wasn't implicit. And one of those things, of course, is call a function. So here is an example. I have a little class that I want to make a proxy for. It has a type alias, a member function, and a static member functions. So all of these are useful thanks to the implicit keyword. I also have a function that takes one of my class objects. So let's create a my class object and create a proxy to it. So now the proxy is like a subclass, an object of a subclass to my class. So obviously I can call a method because there's no such method in proxy itself. So it looks in the base class, which happens to be my class, thanks to the implicit keyword here. And I can call f. I can also access the data member, and I can call the function that takes one of these because it's a base class of my proxy. In all of these cases, the function will be called, of course, to get the reference to my class. These functions are called in all of these cases. And of course, they can do arbitrarily complex stuff here. In this case, it just dereferenced the pointer. So then we have other stuff we can do because it acts like a base class. We can declare an int by using this type alias here through the proxy because type aliases are inherited. And we can create a pointer also to my proxy, and it acts as a subclass to my class, so we can cast a pointer to a my class pointer. But note, my class is not part of the proxy. It's through this pointer. So here it would call the function which returns, no, not there. Well, the arrow operator here will also call the function. I can use it for static method, and I can upcast the pointer implicitly. So why is this important? That's because we have generic code, we have templated code, and it's not enough to be able to do this, or maybe those two in templated code, because it could just as well do any of those things, and we want it to work as my class, except that when we copy it, we don't actually copy it. It's a proxy reference with non-owning semantics. So moving on, we have other kinds of usages. I will show a couple more. This is just a fake example, but there are real examples. So when they designed the SIMD types, you have this AVX or neon word in a register. There is no address for an individual element of that array because it's just part of a register. So how can we make this look like something where we can actually manipulate individual elements? Here we can't extract the third float out of this SIMD because it doesn't have an address. So instead we can have a special reference here. And that reference today, it was such a reference in the proposal, and it had like 18 assignment operators, all of these assignment operators from the T. And still it didn't really work as the T it represents, because you can't do multiply on it because, well, you can, but you can't do other stuff. And this wouldn't work, of course, because, well, with the reference they had, which was really complicated, you get somewhat useful functionality, but it's much easier to just put an implicit here and all of this works automatically. This is somewhat simplified because it does, some things don't happen until the destructor time. So when we do this, the assignment back into X doesn't happen until third is destroyed, which happens down here somewhere. So it's not exactly the same. So that's why I'm working on PXXX here to make it really work the same as if this was an array of float. That's the goal. So that's the SIMD example. And the same can be used for the reference to one of the bits in a vector or bool. Today there's a reference there, but it only works sometimes. So in generic code it usually doesn't work. But with this proposal we can make it at least much closer to the real thing. And moving on, we have these, as I said, interpolation things. You can write like this. So what's the type of A here? Oh, of S here. That should be a string, right? You expect this to be std string. And the problem is here. You can do std print on an std string you'd have to have another string before here with just the curly brace inside to do print. But if we let this literal operation itself return one of these formatted string objects, which has an implicit cast operator to a std string, and we have pxxx, then this would deduce to std string here. That's what the upcoming proposal does. If you deduce auto from this type, it will be a string. So as soon as you have auto here, this is a string. But now we can make a new overload of print that takes one of formatted string, so there's no auto involved here, and then we can extract these values. And not only can we do it, it's much faster than first converting to a std string and then printing the string, because you can stream it out to the output buffer directly. And that's why we got std print in the first place, to avoid using std format and then shifting it out to ostream, losing the optimization of shifting each little part of the compiled string out to the stream. So here's a little bit strange thing, because this is now a formatted string. You can do the size method on it, because this sort of inherits from std string. And of course you can do size on an std string. Finally, you can do file system exists on one of these strings. Although there's both a conversion operator and a constructor of a file system path in series. You can't do that today. If you have both a user-defined conversion and a constructor that needs to be called implicitly, that's not possible. But with this, it doesn't count as a user-defined conversion anymore. We have another example. Sometimes you have a type which is really hard to produce. It could open a network connection and talks to some server somewhere, for instance. But then you have a function that maybe will do this. It will maybe construct the object here. And today there's no way to delay the construction until needed. But of course we can do the construction inside the operator here. So I use an optional to see if this was already called, and I have already produced the value and I return it immediately. Otherwise I just create it by calling the function that's supposed to create the object. So you call the lazy, now I'm there pointing. You call the lazy here with a function that's stored. The function pointer is stored inside, or the lambda or whatever. And then if this unlikely event happens, this operator gets called and it actually calls this function to create the value. If this unlikely event doesn't happen, you don't pay the time to create the value that you don't need. This is really not possible today. And note that this function has not changed. This function does not know there's delayed creation here. So that's something that could be quite easily standardized, I think, once this core language thing is updated. Finally, I think this is the sort of killer app. A regular reference you can always wrap around any pointer, and then you can use dot instead of arrow to access the data inside that the pointer points to. And I sucked in contracts here. Of course we have contracts in this standard version. So I can say that this source pointer is not null. So I know this pointer is not null. So I can just deref it here. And if it's not true, it should either call the contract handler here, or I have undefined behavior down here. That's how contracts work. If you compile without contract checking, it will be problems if you violate the contracts. So note now, we can copy this. We can always copy this unless putter is a unique pointer, then we can only move it. But as we do the copying, we have the same copying, the same ownership semantics as the corresponding pointer type, but we can still use it as if it was the value that the pointer points to. So I think this would be very useful also when you have generic code that wants a value, not a pointer. It uses dot all over the place, but you want it to use a remotely available pointer. Isn't this what you are lacking, Harald?
It solves basically everything.
Well, I think that's taking it a bit too far, but there are definitely lots of places where this would be useful. So this concludes the presentation of this particular proposal. I can finish off by saying that I was successful in the first step of the standardization processing in the last meeting in St. Louis in June. And in the next meeting, I will go into the next step, which is much harder. So we'll see. Maybe in 26, maybe in 29. Do you have any questions or comments on this particular proposal? Yeah?
What happens when you use the example of the proxy? If the proxy has a member which has the same name as the one in my class, does it get shadowed?
Yes, because it works exactly like inheritance.
Yeah.
So it gets hidden actually, not shadowed. And you can use the regular base class : syntax, which I showed on the previous slide actually.
Okay, cool.
And here, what I did was to have an unwrap function that returns the pointer. And this is a friend function. So it's not found by if you use the dot. You have to do unwrap on this guy to get the pointer inside. And that's often useful, I think. But this is not part of the proposal. It's just an example. So another proposal would have to discuss all of the nitty-gritty details of should this be an unwrap or should it be something else. But what I wanted to show is that I don't want to have any members here that you can access. And this should probably have an obscure name because, you know, even if it's private, it's going to hide any putter in the this element type of the PTR type there. So this should have a number of underscores and stuff, I guess. Yeah.
So I imagine then if the proxy, for instance, would also inherit from class whose name clashes, then you would get an ambiguity just as if you inherited from both.
Yes, exactly. That's all in the paper, but it's actually if this guy inherits from another class which has the same method as the element type of the pointer, those would be like if you inherited from both, you would have to disambiguate. So I wouldn't recommend inheriting anything in this kind of class. So the rules are exactly the same. That's actually the big advantage, because if you want to do this like an actual operator dot, where you actually type operator dot in here, then you get into a whole new set of rules you have to define just for these cases, which wins if they're both there and there. Here's no problem. It's just like you inherited. So hopefully that's going to be easier to standardize, because it's all about the corner cases, and it's all about the imagination that there are corner cases that we couldn't find. No one found this corner case, but when we then published the standard, compilers implement it, a lot of code breaks because there was some kind of strange construct in old code that got a new meaning. It's really scary, and that's the worst part of working with this because it takes so much time to figure all those cases out. Not in library so much, but when you work in the core language, yes.
You have to implement it in one of the compilers to get it to
I'm pretty sure I would have to implement, or someone would have to implement this in a compiler because of the risks. It's risk mitigation. I don't think anyone can see it, but there could be something there. Matthias?
Yeah, I understand that you may have more base classes, right? So you may have implicit conversions to other types, and then maybe have like you have 2 or 3 different base classes, right? And
Yeah.
Of those. And I assume that they go to the, let's say, to the end, logically to the end of the list of base classes, if you will implement this traditionally. I mean, like what's the order? If you have a base class in universal ref and you have pointer, then which one is the first one, which one is the second one?
Well, it's still as if you inherited from all of them. So if the name is available in more than one, it's ambiguous.
Yeah, but the order probably should matter, right? For example,
No.
for construction, if you have a constructor trying to initialize both of them, then you may.
Well, the constructor only sees the mputter here. It
Yeah.
doesn't see anything else in this class. And if there are space classes here,
Yeah.
it would see those, of
Yeah,
course.
so
I don't
then
think...
so then the regular base classes are first, and then this one is second.
Yeah, okay, sure. Yeah, there's nothing to do with this proposal, but sure. That's how it always was. Yes.
More like a clarification question,
Mm.
how like the proposal standard works. This from my colleague's
Mm.
question here. Does the standard would require you to have compiler support, or is it more like, yeah, that would be a good idea? Like compared to web standards where you have to have 2 independent implementations.
Yeah, no, there's
Wow.
nothing in the statutes of the standardization process, if there is such a thing. I don't think there is such a thing actually, but there is some kind of practice that's been developed over the years, and it's been stricter and stricter, and it builds on just the fact that someone will say, do you have implementation experience? And if you say no, come back when you have it.
So like legally no, but culturally yes.
Yes.
Okay.
Unless it's a very small and limited feature, then you can maybe...
But I mean, you could theoretically get an approved proposal which is unimplementable. Like theoretically.
Yeah, theoretically, yes, that could happen. It has happened.
Oh.
So, yeah, I think modules did need some changes, yes. So when we started talking about this, I will go into the part that discusses the actual process. So there are a few interesting facts about this standardization process that's not maybe exactly mirroring other kinds of standardization. I think one important difference is that compared to other ISO standards, most of the work is done before ISO gets involved. That's because it's so complicated, and the ISO process is even more slow, and they don't distribute papers very often and so on. Then the second worrying fact is that the committee works mostly on unpaid labor, evenings and weekends. There are a few companies, a few big companies also, that pay a few individuals to actually produce papers and process papers, maybe 10. and the meeting has 150 people, and around 500 are involved, I would say, in different parts. Some companies pay for hotels and trips and so on. My company does that for me. It goes like education on the workplace, because everyone has to get a week of going to a conference or something. But a lot of people pay going to Hawaii or to Bulgaria out of their own pocket just because they want to be part of this. But it's a bit flaky to rely on that for, I guess, the most important programming language we have. So after C++ 11, which was 13 years in the making, it was a policy decision that we will release a standard every 3 years. Whatever we have that's ready will go into that standard. We don't define beforehand what's in the next standard generation.
Yeah, I think it's worth mentioning that 3 years actually is not that long as you may think, because we actually release standard after every 45 days of work. We take 45 days of active work during meetings to standardize a new version, because we meet for 5 days, 3 times a year, for 3 years.
Yeah.
So if you think about it this way, there's actually really short time to release a new version. Of course, we do some progress in between the meetings, but all actual decisions are done mostly during the meetings.
Yeah. True. The standardization is mostly subdivided into core language features like this one I presented, and library features like the one that Mateusz presented. And these have different groups, but all of these groups are meeting in the different rooms during the same weeks. And there's a lot of crosstalk. There's a lot of proposals that have to go to both groups. But many proposals stay in their part of this, and we will see what those groups are later. But all of this, especially that the members of the committee are not employed by some standardization organization, no one can tell them what to do. You can do a proposal that's almost finished and then just disappear. I don't want to do C++ anymore. I changed employer, they don't pay my trips anymore. So it's very vulnerable to all that kinds of things. And there are lots of proposals that are half finished but have been since maybe 10 years just idling. That's very unfortunate. And finally, you can't even charge these guys for going to the meeting. So someone has to sponsor the meeting, like here, but on a larger scale, because it's more people for a longer time. So it's really hard to find sponsors for meetings. I started an effort together with Harald to try to host a meeting in Stockholm. It would have been now this summer instead of St. Louis, but we couldn't find sponsors. It was really hard. So if you have any ideas, please contact me or Harald how we could arrange a meeting. It's mostly about finding the rooms, like this place, but 3 times larger.
Bigger.
We need 200 people in the largest room. We need a couple of rooms for 50 and so on. So waterfront would be nice. But who has that wallet? That's the problem. So, okay, that about the organization as such and what the computing society and the society at large are relying on for getting this done. And as you know, the compilers, most of the compilers is the same story. no one's paying, and we rely on these compilers to implement the new standards. Who is doing that actually? That's why they claim they require you to do the implementation first, because then it's already implemented and it's much easier to get it implemented if it's already implemented actually. So the process itself starts obviously with someone coming up with an idea or a problem that needs to be solved, and you saw my lists of things I think needs to be solved. So think about what you need to be solved, write the paper, and get involved. Once you have sort of a solution, you start writing a proposal usually, or you can implement it first. And then you find like 100 corner cases you didn't think about, and the paper gets 5 times longer than you thought, and it takes forever to write, more or less. But it's a rewarding accomplishment, I think, to have thought about all these details, all these small cases that occur. So once it gets into the meeting rooms, it starts usually in this, which is called incubators. This is for core language, this is for library. These are small groups where it's rather informal. You present your proposal, they tell you what things you didn't think about, what you should add to the next version of the proposal, and you can iterate here a couple of times, because even there they won't let you go on to the next level until it's reasonably good. And I presented 2 proposals in St. Louis. This one went to the next level, while the other one, they wanted me to basically split it into 2 papers, I think, or remove 1/2 of it, maybe. It's hard to see. So some specific tasks are so large, they have their own study group. So you don't present your proposal to one of these generics. You present it to, for instance, the machine learning group, or the contracts group, the networking group, and so on. There are about 20 of these. Usually, most of them only have 1 day of meetings in each meeting. Contracts is all week. A lot to discuss there. So once it gets polished enough, it goes to these main groups where all the design is done. Everything should be finalized. We know exactly what we want to do. And then it goes to the final groups, which are the wording groups. And they only focus on getting the wording, the actual English in the standard to correspond to what you mean by this feature. And that's not easy, as you know, when you write documentation.
Yeah, some people don't agree. It's not English, it's standardizing.
Standard.
It's a different language.
Yeah, it's very, it's formalized to a level where you more or less know how you have to formulate each sentence to convey a message. And it has to be that way, because otherwise everyone is going to interpret the standard differently. So there's 2 of those groups, and there's usually 10 people in each group, and they don't interact much with the rest of the meeting. They just get more and more wordings in different proposal, and they integrate it, and this is all done in GitHub. Each proposal has its own pull request. So once it's voted into the standard on the, as I said, the informal pre-processing level, the pull request is merged into the draft standard documents. And then when 3 years has passed, the draft standard with all the pull requests so far is locked, and then it progresses to the actual ISO level. And what happens next is that it's sent out to all countries, because it's international. It has to be agreed upon by all the countries. So that's the official task of our little AG09 group, is to oppose to or approve the next draft standard. And then, of course, after a period of thinking there, it goes into actually being the standard, the next level standard. But there's a lot of comments coming back. You didn't think about that. You're not following the conventions here. There are too many tabs here. There should be spaces. It's all the levels. And ISO has their own people who check that it follows their typographical rules and stuff, and there's hundreds of comments from them for each level, for each new version. So of course this process takes a long time, and I think 2 years is the minimum. This meeting in the autumn, I heard, is the last meeting when a new feature can be presented to these groups. If it's not presented there, it's not going to be in 26. And that's the end of 24. And the standard is that's actually 2 years from there until the draft is moved to ISO level.
Yeah, but we still can add new things, but those things are typically bug fixes. So this is like a feature freeze, right? It's feature freeze, and then we have a year to stabilize the product. So we have the entire year to do it.
Yes, of course.
And then we do actually close at the February meeting of this year. So like February 2024, 24 gets released, right?
23 gets
23, yeah, 23
frozen, finally, yes.
So and we hope that from February until December, ISO will actually publish the document, which didn't happen for 23.
Yes, I think it's published now, but it wasn't within 23.
I'm not sure if it was published, but for sure it was not announced loudly because we
Yeah,
failed
okay.
to deliver a year ago.
So
Previous year.
there can be problems, of course, even if the standard document passes all of these levels, and mainly that's when more compiler vendors start to implement the feature, and maybe they figure out that, oh, I don't know how to do this. It could be that way or it could be that way. While the first compiler implementer, he was sure it's this way. Worst case is when two of them are sure in different ways. And that happens quite often. And then some user figures out that this code is not portable. So why isn't it portable? Because these two compiler vendors interpreted the standard differently. And this happens all the time. So defect reports are the means to try to fill those gaps and define which of these two is the right way to do it. And this takes a lot of the committee time also. And this can be back fixes to 2011 or even C++ 98. It's been undefined even since then. So here is how it should be. So it can take a long time until someone discovers that's actually different. So now to some more fun parts, I think. Yes?
Is there any way that you can be sure, like from this level, it's gonna go somewhere, or is like at every level in this process, it can just stop and you're
It can always stop, and one simple reason it stops is that the author can't cope with the workload or starts coding in Rust.
Did that happen?
Oh yes. The original author of this string interpolation proposal has already left. Before it's even a P number.
Yeah, plenty of Google guys left from the committee, but this was about the ABI discussion, if you've heard about it.
Yeah, and they started their own language instead. Yes.
So this draft is public access, right? You don't have to purchase it, but the standard,
Right.
standard is.
Yeah. I will show you links.
What's the diff between them? Like, can it not be a draft before it becomes?
I don't know exactly. I'm thinking that probably ISO don't want you to publish the last draft, which is exactly word by word the same as the standard. But I'm not sure.
It includes the word draft, it is not word by word.
True.
Yeah, but
But maybe it's exactly the same except for that one word. But it's surely very close. And it's publicly available.
But as part of the working group, do you have access to the ISO standards, or do you need an entity that sponsors you to get access to the actual written standard?
We need that entity, yes.
Okay,
No,
so even you don't have
no,
access.
sorry. Wrong. No, I have. Because if you're an AG 09, you have access to all the documents for the languages that this group SC22
It is, but it's
is
also so that companies
standardizing.
are very often ISO members or members at CIS,
Yeah.
and then your company has access to these documents.
Yeah.
And if you're interested as a private, then you take the N number that became the standard, and you get this.
Yeah,
basically
the
it's
last
word
draft
document.
is
So it's not
a
nothing-
good approximation at least. Okay, so the last point I want to make here is to show you, unless you already know, what we standardized in C++23, which is a really minor update from 20. We got the explicit object parameter that,
Not me, Casper.
yeah, but you said you used it.
Yeah, I use it, yeah.
Yeah. We got the multi-dimensional square bracket finally, and we got MDSpan, which is a view into a multi-dimensional array. You need to have the storage underneath, but that's going to be fixed in 26, I hope. There are some cases when a range-based for could dangle references in the expression, which has been fixed. So all the temporaries needed to create the range that you iterate over are kept until the for loop finishes finally. You can get a stack trace, which can be useful in debugging. And it has some methods to get the name of all the functions you have called. You can call this guy whenever you want. And I think you can call it with an exception, or construct it from an exception pointer. So where was this exception thrown? I'm not really sure about that, but I think so. We have this little class expected, which can convey as the return value either the value or some kind of error code. And then you can ask this one, did you get an error code or did you get the actual value? So you don't have to have like an extra string where you put the error message like an in-out parameter or something. It's more convenient to use expected, and it has some kind of nice ways to tell it that I'm now returning the error code, now I'm returning the value. Talked about that. We have also new map and set based on vectors instead of trees of nodes, or hash map has an array and then it has some linked lists for each bin or something. This is just 2 or 1 vector, and it uses binary search to find the elements. And if you have less than 100 elements, I think it's probably faster than the other ones. STD print, I showed you STD print, but it's just like STD format, but it outputs to to see out immediately. There's a helper for coroutines, so you can easily make a generator, which is like you do for over a function, and the function yields all the values one at a time using co-yield. So it's basically a shortcut when you don't understand how to make a coroutine. So it's very valuable for me. If your compiler supports modules, there is just to import std semicolon instead of including any headers, as long as it's fully implemented. And those that have it implemented has said that it's about 10 times faster than including all of the std headers. So it's going to have a massive impact on compile times. Modules in general, of course, but just using this guy instead of including string and ostream and all of that. And you don't have to think about what you include. std format, the format string is checked to be compatible with the arguments at compile time. That's a lot of compile time programming to achieve that, but it's standardized that it shall be done. So that's 23, and I don't know if any compiler has completed this, I don't think. But bits and parts of it are available in different compilers. So going over to 26, we're in the middle of the process. These are the things that have been, the PRs for these have been merged in GitHub. So they're in the draft document. As you can see, the list is quite short still. In static assert, if you can figure out a way to call a function that returns a string at compile time, you can get it out on the console when you're compiling. And there is more work in that direction being done, so you can have like a static message, so you can debug which template instances were actually instantiated, which I find very compelling. You can use underscore as an unusable identifier that you can use many times. So if you declare variable like a scope guard, which you don't plan to use, give it the underscore as a name, as in many other languages. But of course, being backward compatible, if you only have one, you can use it. If you have two, you can't use any of them. So that's the kind of fixes we have to make for backward compatibility. If you have a pack, a variadic template pack, you can actually get an element relatively easy now, and this is going to have a lot of compile time improvements in things like tuple, where you can just access the guy instead of doing a massive tree search in lots of template instantiations all run at compile time. There was a problem in toString, so if you set the global locale, you could get the comma instead of a point in floating point numbers. It's been fixed. Now that in 23 there was compile time checking of std format. Now we can't use a std string as the first argument anymore if we want to make the format string at runtime. So now that was fixed by another thing. So this is a function that you call with your std string as a parameter. It returns something that std format can use as the format string. I don't know what. This was also one of these little mistakes. You couldn't concatenate a string with a string view because there was no operator plus. Fairly easy to get into the standard. It still consumed a week or so to standardize. You have heard of BLAST. That's a Fortran library, Fortran library. to do matrix multiplications, basically. That has been ported to C++ with all of the template magic to make it even faster than in Fortran. And finally, we have an in-place vector here, which is in the middle between std vector and std array. It's like an array when it comes to allocation. It's already inside the object, but it's like a vector because it can grow and shrink, and the other elements beyond the size are not constructed yet. So don't overflow it, otherwise it's often faster than vector because you don't have to do a malloc to get your memory. And for embedded, it's often not useful with vector because you don't have any heap. This guy you can use anyway. What's cooking in the standardization committee? That's a lot, and if we get all of that into 26, we have a major release. I don't think we should have too high hopes, but some of these things will probably land in 26. I had to break it up into 2 slides because there's so many things. For me, static reflection is the primary thing, and it's doing good progress. This means that you can, at compile time, take your struct and ask the compiler, what are the members, what are their types, what are their names. I can make a print all structs function. You can put any struct in there and it will print the members. That's about 2 minutes work with this proposal. And you can serialize and deserialize, trivial. A lot of stuff happening there. And follow-up proposals will also allow you to use this information to generate code, any type of code that needs to know about these things. For instance, you can do a toString for your enum that prints the text values of the enumerators. That's a standard example. Contracts, I've talked a little bit about contracts, as you put pre and post and some expression. It seems very simple. But then you're talking about UB, you're talking about what happens if an exception is thrown while calculating the value, true or false there. What happens if I inherit from this function that has the contract? What happens if I take a function pointer to it? It's brutally complicated, and there's so many different opinions, and everyone knows exactly how to do it, but no one agrees, unfortunately. So that's why a study group has spent 3, 4, 5 meetings full time to just discuss contracts. We'll see if we get anything. Maybe we get the technical specification, which is sort of an appendix to the standard, which compiler vendors can implement if they want to get more experience. Whoa.